It's actually quite big. If you go through the numbers, the volume is 4/3 pi r cubed, where r is the radius of the object. If you do that, the volume turns out to be about 2.2 billion cubic meters. So an object of a size of 2.2 billion cubic meters hits the Earth about every million years. Much smaller objects hit much more frequently, but let's talk about that, something like that, because that will really probably wipe out a large fraction of humanity if it happened, if we're still around when it happens. Let's suppose that this object had the density of water. So clearly a comet would be have about that density. And actually, if it's a stony object, a metallic type meteor thing, its density would be somewhat higher. But let's take the more lenient case of water. Now, water is about 1 cubic meter of water weighs 1,000 kilograms. Again, going to pounds, that would be about 2,200 pounds. So 1 cubic meter, it's kind of like, kind of like me. I'm almost a cubic meter if I ever stood up and you looked at my belly. Is about 2,000 pounds, so guess I'm about 1/10 of that, more or less, a little more actually. But let's get back to this. So if I had an object that was a cubic mile in radius, made out of water, its mass would be about 2 trillion kilograms. 2 trillion kilograms. It's pretty darn big. Of course, much, much smaller than the mass of the Earth. Now let's talk about the energy of this thing. How fast would it be traveling? Well, the velocity of these things typically are 30,000 miles per hour. Now, how do I say that? Just look at the speed of the Earth orbiting the Sun. The Earth orbits the Sun at about 66,000 miles per hour. So we're talking about things on the order of tens of thousands of miles per hour. Assuming that, what's the energy that's going to be created? Well, energy is equal to the mass times the square of the velocity times 0.5. In other words, the kinetic energy of an object, if we're sitting here on Earth, if something hits us with some relative speed, the velocity comes in, the energy is equal to 1/2 mv squared. The bigger the mass, the bigger the impact. The bigger the velocity even bigger impact because it goes as the square. So if we have that, the energy comes out to be about 2 times 10 to the 20th joules. For you guys who have taken some physics, that's a big number. In terms of numbers we're more used to, a lot of times we use the equivalent of a ton of TNT. 1 ton of TNT is about 4 billion joules. So it turns out that an asteroid hitting us of that size would correspond to about 45 billion tons of TNT. 45 billion tons. So let's compare that. Well, that would be about 45,000 megatons. Compare that to the atomic bombs, which are the most explosive bombs we have. When the bomb exploded in Hiroshima, back in 1945 or so, the United States detonated an atomic bomb over Hiroshima, Japan, to help expedite the end of World War II. Turns out that bomb, which devastated the city, killed over 70,000 people, wounded about another 200,000. The city was basically destroyed. That bomb was 15,000 kilotons. Compare that to 45,000 million kilotons. It's no comparison. So if an object that size hit the Earth, it would just make a total mess. That energy would come in, and it would, if it hit the land, this energy would melt, create a giant crater, and a tremendous amount of debris would be ejected into the atmosphere. That debris would remain in the atmosphere for years. The Earth would be shrouded in a cloud. The surface of the Earth would be dark. No sunlight would come through. All plants would stop growing that we know of. And there would be mass starvation. So this is one of the impacts. There would be a mass starvation of humans. The impact itself, depending on where it hit, say if it hit in eastern United States or it hit in a part of Western Europe, maybe 1 billion people, hundreds of millions of people would be killed on the impact, up to that much. But then after that, that dark cloud will come and freeze the earth, and we'll all starve to death in darkness. The other possibility, of course, is that such an object will hit the ocean. And that'll still be a mess, because what will happen is when this thing hits the water, it's going to create a tremendous tsunami. And that tsunami, in of itself, will affect our environment. So this stuff is really bad. It will happen. Sorry to say that. We can talk next time about how can we actually prevent something like this from happening. Last point I want to make. You might say, well, we've got the atmosphere up there, and the atmosphere is going to, kind of evaporate all this stuff away, especially this water. So by the time this thing hits the ground, it's going to be steam. Now, let me give you a little demo of that. I'm showing you my skills at throwing a grapefruit up in the air and catching it. 1 1,000, 2 1,000. Okay, 1 1,000, 2 1,000. Something traveling at 30,000 miles an hour. It's going to pass through the atmosphere in about the time the grapefruit left my hand and then re-entered it. In other words, it's way, way too fast. So that's it for today. Hope this was useful. Take care, and watch out for your meteors and asteroids.